Okay, guys, here we are with chemical reactions, and today we're going to talk a little bit about chemical reactions, and we're going to learn how to balance these chemical equations. Not gonna lie, it's gonna be a little difficult for me to do this without a whiteboard on a computer, but I'm gonna do my best, so bear with me. Okay, so all chemical reactions. So in a chemical equation, right, we have, and I got the pointer thing to work a little better. We have the reactants and the products, right? So the reactants are what we start with, and the products are what's produced or what we end with. So let me see if I can't add that. Sorry, guys. Well, that's a little large, but that's what we end with. And we also have our reactants, right, which is what goes on the left side of the equation. That's really important. That's what we start with. And what we end with is what goes on the right side of the equation. And we have this arrow here in the middle, right? And that means whatever's over here is becoming what is the products, right? So the reactants are going into the products. Basically, the reactants are what you start with, the products are what you end with. And chemical equations also can have something called a catalyst. That's something that helps speed up the reaction. It's usually written right above the arrow right here. It's not super important that we understand that. It's just good to know, right? And it's not used in the reaction. Right, so here is an example of a catalyst right here. Right, you can see it's above the arrow. It's not in the reactants. It's not in the products. Okay, there's also several different symbols that are used in the chemical equation stuff. So let me freeze this so I can type. So we have a plus symbol, right? That just means whatever is added together. So there could be two reactants and they are added together. Again, the arrow, right? That's the reaction. S means solid, so that element is in a solid form or a liquid form or a gas form. Aqueous is something new. So this is often put behind a letter. So let me type an example of this out. So you could say, let's say we have iron, and then it would be AQ in the back, right? So this is aqueous iron. And all aqueous means is iron in water, right? So aqueous just means whatever that substance is within water. So it's just like a solution, right? So you could say aqueous sugar, and that would be sugar mixed with water. These last two are not as important, so don't worry so much about them. Okay. So we're just going to discuss briefly how to talk about chemical equations, right? So in this example down here, let's get rid of that. In this example down here, we have aluminum plus iron, arrow, aluminum oxide, iron. And so if we want to turn these words into more of an equation, right? So an equation meaning we have the actual letters and numbers versus the words, right? So we don't want the words, we want the letters and numbers when we're writing an equation. So just like in math, right? You're looking for letters and numbers, not entire words. You can also go the other direction, or you can go even more extreme, right? If we say iron and chlorine gas react to produce the salt, right? Then you turn iron and chlorine. Again, this is not that important. You can also go the other direction, right? So if I were to talk about I were to turn this into words, right, you might say like iron plus chlorine reacts to produce iron chloride, right? Sorry about the phone. Again, this is not the most important part. It's just showing you how to sort of write the equations and talk about the equations. Okay, so we're gonna actually skip that into this. So there are a couple of different things we want to talk about, which are coefficients and subscripts, right? And also the conservation of matter. So we're going to jump ahead on your note sheet to the conservation of matter. The big idea here is that matter is never created or destroyed. And what that means in a chemical equation is you need to have equal amounts of each element on both sides of the equation, right? So we will look at how to balance an equation just in a minute. But the big idea is if you have 2 oxygen as a reactant, you need to have 2 oxygens as a product, right? You're not getting rid of oxygen, they're not leaving the equation. And we do that by working with things called coefficients and subscripts. So let's take a closer look at this little box right here. So you may notice there's small letters down here, and by this point we all know what that means, right? It means that there are 2 hydrogen, and these are called subscripts, right? Let me see if I can't put that in right here. Can we make our text smaller? Subscripts, right? Versus right up here where we have this big 3, and that is called a coefficient, right? So if you put the 3 in front, that means you times the 3 by the 2 to get 6 hydrogen and 3 by 1, oops, sorry guys, to get 3 oxygen. The big idea is that the subscripts down here, right, those are permanent. We can't change those. It's always going to be H2O. The thing we can change are the coefficients right up here, right? So we can change, right, the coefficients. So we are going to now practice balancing an equation. And I know it's a little bit confusing, but hopefully with practice, we'll get a sense of how to do this. So I'm going to walk you through the steps. So here we have our equation, right? H2 plus O2 equals H2O, right? So hydrogen plus oxygen equals water. And the very first thing we're going to do is we're going to draw a line down from the arrow, right? So we're going to divide that in half, and we're going to count how many hydrogen we have, how many oxygen we have on this side, right? And then we're going to count how many hydrogen and how many oxygen we have on this side. So we're counting each side of the arrow, right? So we have 2 hydrogen and 2 oxygen, and over here we have 2 hydrogen and 1 oxygen. So this is the problem right here, because if we follow the conservation of mass, we need to have equal amounts, right? This needs to be equal. We need to have equal amounts of hydrogen, and this needs to be equal. And as you can see, we do not have equal amounts of oxygen. So I'm going to go ahead and write that. We do not have equal amounts of oxygen. Right? So that's a problem. So that is going to lead us into our step number 2, which is just to determine which elements are not equal. So we kind of already did this. Hydrogen, right? We have 2 of each of those, so we're all good, but we do not have equal amounts of oxygen. So how do we fix that? We fix that with coefficients. So step 3 is to add a coefficient to make them equal. So what we want to do is figure out how we can make, let me unfreeze that, how we can make our oxygen equal, and to get 1 to equal 2, right? Sorry guys. To get 1 to equal 2, we need to times 1 by 2, right? And then we have 2. So once we get there, this is just showing that step, so we can cross this off, and now we have 2 oxygen and 2 oxygen, they're equal. But since we multiplied this by 2, we have to put that 2, we have to take that 2 and put it up here as a coefficient. Now note, we are putting this in front of the oxygen, right? Because that's the one we're multiplying by 2. We're saying we need 2 oxygen. We're going to multiply that oxygen by 2. We're putting it on this side of the equation because we're changing these numbers, right? We're not doing anything over here because we're not changing that over there. We're just changing the products right now, and we're multiplying it by 2 because we need it to be equal. Okay, I know this is a little confusing. It's just going to take some practice. So let's move on to the next slide. So step 4, we encountered a problem though when we multiplied this by 2. We need to recount. Oh, my dog is stepping on my computer. Okay, sorry. So we need to recount how many of each we have, because since we put this 2 in front of here, now all of a sudden we have 2 oxygen, but we have 4 hydrogen, right? Because 2 times 2 is 4. So we have 4 hydrogen. So now we're back to where we started with, right? Our oxygen are equal, but our hydrogen are not equal. This is bad. We still don't have conservation of mass. So, again, nothing has changed on this side of the equation, right? Everything's still the same. But now we have a problem again. So what we do next is we just go back and do the same steps we did in steps 3 and 4, right? We determine that hydrogen is unequal, right? Which means that we need to equalize it. So how are we going to do that? So how to get 2 equal to 4, right? So what we're going to do is we're going to times this by 2, right? Because that's going to make it equal to 4. And then we'll have 4 hydrogen on this side and 4 hydrogen on that side. And since we times it by 2, we're going to take this 2, put it in front of the hydrogen. We're not putting it in front of the oxygen because we're changing hydrogen, so it goes in front of the hydrogen. So we're going to put a little 2 here. We don't put 4, right? We put the 2. And that's what we're going to see in this next slide, right? So we multiply this by 2, and that's equal to 4. Okay, and that's equal to 4, right? So we cross that off. Now we have 4. Let me actually freeze this. So we cross that off. Now we have 4, and we have 4 over here. And we put that 2, that multiplied 2, up as a coefficient, right? So now we need to check. Do we have equal amounts of oxygen? We do. Do we have equal amounts of hydrogen? We do, right? So we have a balanced equation, right? And what you would write in the end is this top equation right here with our coefficients, right? So we have a total of 4 hydrogen on this side, total of 4 hydrogen on this side, total of 2 oxygen on this side, and a total of 2 oxygen on this side. So our elements are all equal. We have reached the conservation of mass. Yay, we're done. Okay, so those are the steps. I'm going to do one more, maybe another to just practice. But if you feel confident now, you can go ahead and try it on your own. I'm going to do another couple just to show you what's going on. Okay, so this is a little hard to read, but we're going to do our little balance equation, right? So here we go. We're going to divide, right? And then we're going to type. We have zinc is an element. Oh God, hold on, I forgot to freeze it. Hold on. Sorry, I'm still struggling to learn some of this tech stuff. Okay, we have zinc is an element. We have sulfur as an element. And we have oxygen as an element. And to start, we're going to start with, we have 1 zinc, right? We have 1 sulfur. Oh, let me make that black. 1. and we have 2 oxygen, right? We got all of that from just the reactant side of the equation. So now we're going to go over here and do the same thing. So we have zinc. Let me make this all the same color. Hate my life. Okay. We have zinc. Sorry to those of you who it's going to bother that it's a slightly different red. We have sulfur. Again, we want to make sure we put these in the correct order so that they match on either side, right? And then we have oxygen. And then we're going to fill in what numbers we have. So I'm going to make it black again. So for zinc, we have, oh my God, we have 1. For sulfur, we have 1. And for oxygen, we have 1, 2, 3, right? So this is step 1. All we've done is determine how many on each side of the equation we have, right? And so then we go to step 2. We see that zinc is equal. We see that sulfur is equal, but oxygen is not equal. And here we come to a different problem, right? We need to make sure oxygen becomes equal, but you can't multiply 2 by anything to get 3, right? So we have to figure out what number 2 and 3 go into, and that number is 6. So what we're going to do is we're going to do 2 times 3 equals 6, right? And then over here, we're going to do 3 times 2 equals 6. So we get 6 on both sides, right? And on this side, we multiplied by 3, and on this side, we multiplied by 2. So now we need to take those up into the top, right? So 3 goes right in front of here, right? As a coefficient, it came from down here. And here, we need to choose which one we're going to put the 2 in front of. It doesn't matter. It's usually better to put it right in front of this, but we might have to change things. So we're going to put the 2 in front of here, right? So now we're doing pretty good, right? So we have 6 over here and 6 over here. But since we put over here, we put 3 in front of oxygen, doesn't matter. Over here, though, we put 2 in front of our zinc, right? So now we no longer have 1 here. We have 2. And it's a nightmare again. Again, now our zinc are not equal. So we must make our zinc equal, right? So we're gonna do 1 times 2 equals 2. So now we need to put our 2 in front of our zinc. So we put our 2 in front of our zinc. We put our 2 in front of our zinc, right? So now zinc is equal, but sulfur is there. So now sulfur is not equal to 1. Sulfur is equal to 2. And now we have to make this equal, right? So we're going to multiply this by 2. Which is going to equal 2, right? So then we have to put this 2 in front of our sulfur. Oh my God, this is getting complicated. So this goes away. And now we have to recalculate our oxygen. Remember, you always have to double check that when you put that coefficient in front, it doesn't change anything else, right? So how many oxygen do we now have? So we have 2 oxygens, 3, 4, 5, 6. Wait, 1, 2. I guess we have 6. Why did that not make sense? Oh, maybe we're good to go. Maybe I messed up earlier. Okay, in any case, we now have 6 oxygen, right? And now we have 6 oxygen. So is everything equal? I messed up a little bit earlier, but it all worked out. Sorry, guys. We're going to do one more after this. So these are equal, right? We have 2 zinc, 2 zinc. Sulfur is equal, we have 2 and 2. And oxygen is equal, we have 2 and 2. So we now have a balanced equation. I will type it out for us. We have 2 zinc, sulfur plus 3 oxygen, 3 O2. Ugh, I'm gonna have to write it out. Hold on. It won't let me do subscripts on here. So we have 2 zinc, sulfur plus 3 oxygen turns into 2 zinc, oxygen plus 2 SO2. And we know from looking up here that everything is equal on this side of the equation and on this side of the equation. Yay, we're done. Okay, we're gonna do another one. I'm sorry about the little mistake here. I'm not gonna go back and refilm this so that it's correct. It's just not gonna happen, sorry. Okay, so now we're gonna do this one. Okay,